Topic of today's lecture is reading and writing to files, or to and from files. Or input and output, as it's otherwise called. Okay, so most programs that you write, except for the small little programs you tend to write for assignments, tend to need to perform some sort of input, so reading of data, or output, writing of data, or both. So the way that the C language handles this is that it tries to avoid exposing the programmer to the very low-level details of transferring data from, I guess, memory to a file, or from a file back into memory. Right? There's other places you can get information from as well, right? So you can read from a network, you could read from some sort of device, like a mouse, or a keyboard, or other things like that. And so we're going to look at the higher level stuff. There is a way to access a lower level form of I/O, so very primitive I/O where you're actually reading bits and bytes of data, but we're not going to do that in this course. Okay, so like in Bash, C has this notion of streams, right? So streams of information, right? Which is just a sequence of characters or bytes in C. So the way that you access stream data in C is through something called a file, a big F, all caps file, right? So there's this data structure that has that name right there, big F, big I, big L, big E. It's defined in standard io.h, or declared in standard io.h. You can't actually see the definition of it, so this is one of these opaque types that we've been talking about in C, right? So it's sort of like our list or stack class, data structure, right? File is another one of these data structures. The header file gives you access to one of these types, but you can't actually see what's in one of these. What's exactly inside one of these probably changes from compiler to compiler and from operating system to operating system. All that you need to know is that one of these things, right, so one of these file objects store all the information you need, all the information that the library needs to control an input or output stream. And so if you click on that link there, that'll take you to the documentation for that data structure right there. All right, so this is what's actually inside the compiler manual. Right? So the manual says, right, or the C for, this is the, not the compiler, this is GNU's libc implementation, right? So the implementation of the standard C library. Right, it says file objects are allocated and managed internally by the input-output library functions, right? Don't try to make one yourself. Right? Don't try to use just a plain old file object, right? You should always be accessing these things via a pointer to a file object, right? So in other words, whenever you're working with one of these things, you're always working with a pointer, right? You can dereference it and get the object, but you can't see what's in the object anyway, so there's no way for you to access the members of that object, right? And furthermore, those aren't really useful to you. Those are, the information that's stored in this thing is useful to the underlying library that actually does the reading and writing. Right, so you're always accessing a file or a stream via one of these things here. Right? So via a pointer to a big file object. So like in Bash, you get 3 standard streams for free. Right? So as soon as your program starts to run, 3 streams are opened. Right? So standard in, standard out, and standard error. They're the exact same things as they are in Bash. Right? Standard in, normally connected to your keyboard, at least on a desktop computer. Standard out would be connected to your terminal, again on a desktop computer. And standard error would also normally be connected to your terminal, again on a desktop computer. Right, if you're on an embedded computer or something else, these aren't necessarily available to you. Okay, so when you read or write from a file, often the operation of reading or writing is what's called buffered. Right, so you can ask for, say, a character from a file, but you probably won't get that. You probably won't get that character immediately. Right, so what happens is when you make a read or write request, typically these operations are much more expensive than reading or writing to memory. Right, so in other words, accessing a variable in memory. So reading to a disk is literally many orders of magnitude slower than reading from memory. Right, we're talking thousands, tens of thousands, or millions of times slower. And so rather than wasting all of that time waiting for this read or write operation to complete, the libraries buffer these operations, right? So you make a request to read something. Typically what happens is you're going to make another request to read something else, right? And so what happens is that request gets held somewhere, right? Eventually it gets fulfilled, reads that into some memory somewhere, and then that memory gets transferred to you, gets transferred back to you. Right? Okay, so your streams can be in one of three buffered states, right? So there's unbuffered. So unbuffered means that when you make a read or write request, it happens immediately. So for example, standard error on a Linux system, standard error on a Linux system might be unbuffered, right? Because when you print an error message to standard error, you probably want whoever is looking at the console to know that an error has occurred, right? You don't want to wait for the buffering to happen. So a few seconds later, they get a message that something has occurred, right? So standard error might be unbuffered. It really depends on how your operating system is configured. Oh, what's going on? Okay, fully buffered. And so fully buffered, whenever you make a read or write request, the information that is read or written goes into an array somewhere. When that array is full, then it gets transferred to the device or back to you, right? And so that's called fully buffered. If you read or write to a file, then typically that operation is fully buffered, right? So if you write one character to a file, that character probably doesn't go to the file directly, right? It goes into some array somewhere, and then when you write some more stuff into the array and the array becomes full, or you flush the buffer, that's when the information gets sent to the file. Right? And then finally, there's line buffered. So we saw this in Bash. A lot of the operations in Bash, you have to type something in and press enter, right? And so those types of operations are line buffered. So data is transferred. I don't know what's going on with my computer. Data is transferred as whole lines, right? So whenever it sees a new line character, that's when it transfers the information, right? And typically, standard out and standard in are line buffered. Right? So in other words, in order to, if you type a command into Bash, you have to press enter for the terminal to process that command, right? So it's looking for that new line character. All right, so opening streams. So before you can actually read or write to a file, you have to open the stream that corresponds to the file. Right? And so the function that does that is called fopen. Right? So fopen returns a pointer to a file object. Right? You give it a file name, so that's the name of the file that you want to open. And you pass in another string, that's the mode. So that's how you want to access the file. So do you want to read from the file? Do you want to write to the file? Do you want to append to the end of the file, or do you want to do more than one of these things? Right? Okay, so if fopen succeeds, you get a pointer to a file object, and now you can use that file object to read or write, right? If it fails, then you get back null, right? So your pointer comes back as null, which indicates that you can't read or write to this file, right? And there's lots of reasons why you can't read or write from a file, right? So you may not have permission to read or write to the file. The file may not exist. There might be something wrong with your disk or something like that, right? So there's lots of reasons why I/O operations can fail. And one of the big pain in the butts is dealing with what happens. So when you're reading or when you're doing I/O, there's a lot of error handling that's involved, right? You read something, you test whether or not it successfully got read, right? You write something, you have to test whether or not it successfully wrote, right? And so on and so on and so forth. So dealing with I/O is a little bit tedious and error prone. Okay, so you can open up a file in one of 6 modes, right? So RW and A, so that would be the second string that you pass in, right? That's just read, write, and append. Right? So when you read from a file, that opens up for reading. It starts to, your pointer, your file pointer object, your object that points to the file, it will start reading from the start of the file. Right? If file doesn't exist, you get back a null pointer. If you want to write to a file, it's W, right? Writing to a file, so this is a bit unusual in C. When you request to write to a file, it deletes the file, right? So if you pass in W, you end up deleting the existing file or creating a new file if the file doesn't exist, right? So you want to write to a file when you want to create a new file. If you want to add to a file, you can only add at the end. right? And so this is another unusual thing in C. There's no way for you to write into the middle of a file. And we'll see that maybe today or tomorrow. Or in the next lecture. Right? So you can append at the end, but there's no way to insert into the middle. If you use the plus character in the mode, then you open up the file in what's called extended mode. Extended mode means you can read or write, so you can do both operations. Right? The differences are exactly what happens if the file exists or if it doesn't exist. Right? Are they actually? Yeah. So they're not actually that different compared to their RW and A counterparts. Right? The main difference is that you can both read and write to the file at the same time. Okay. So when you open a file, you allocate a file object somewhere, and you get back a pointer. So that actually causes your operating system to allocate resources to that file. Right? So in Linux, you can only open up so many files at the same time. Right? So you can only have so many open file streams. I don't know what the exact default number is, and the default number can be changed. Right? But there's a finite number of them. Right? And so if you repeatedly open a file without closing it, so imagine you had a loop. Inside the loop, you're just opening a file over and over and over and over again. Right? Eventually, the operating system will run out of resources for opening files. Right? That causes bad things to happen. Right? Typically, that will lock up, in Linux, it'll lock up your operating system. Right? So you'll have to reboot to get your operating system back. So when you open a file, it's important that you remember to close it when you no longer need it. Right? And so the command, or the function to close it is just fclose. Right? So fclose, pass in your pointer to a file that you want to close. Right? Any information that needs to be written to the file that's still sitting in a buffer somewhere, that gets sent to the file. Right? So it's delivered to the operating system so that the operating system can deal with writing to the file or complete writing to the file. Right? If you're reading from a file and you close it, then any of the information that was buffered just gets thrown away. But you're closing the file anyway, so that's probably what you wanted to happen. Now, oddly enough, fclose can fail, which is a little bit odd, but it can. Right? And so if it does fail, then the integer value you get back, right, that int value you get back is equal to EOF. So that's some constant that the C standard defines. Right, so you get back EOF. You normally can't do anything about this anyway. Right? So if you fail to close a file, there's nothing that the programmer can do about this. Right? So no one ever checks the return value of fclose. Right? So in other words, you just call fclose and you don't worry about the return value. If fclose fails, you still can't use the file anyway. Right? So the stream that you just tried to close, even if fclose fails, is no longer valid. So it doesn't matter if you try to do something about whether or not you look at the return value in this case. Okay, so how do you actually read stuff once you've opened up a file? So there's many ways to read stuff from a file in C. Right, you can try to read in the information character by character. You can try to read it in string by string, line by line. And then you can also read it in some sort of formatted, you can read in what's called formatted information. Right? So you can try to read in an integer or a double or a string or a character or some specific character and so on and so on and so forth. Right? And so there's lots of different functions that are involved in input and output, and you have to be aware of all of them because you need to pick the most appropriate one to use. Okay, so if you want to read a file character by character, then the function that you want to use is fgetC. Right? So fgetC reads the next character that's available on that input stream, right? It returns that character as an unsigned char, right? Converted back to an int. But this is all of that stuff is for historical reasons. Right? If it fails, so if it can't read a character from the input stream, you get back this constant EOF again. Right? And so, for example, you would fail reading from a fgetc would fail if you got to the end of the file and tried to read in another character, for example. Right? It would fail. There's lots of ways it could fail. Right? If someone else closed the file, it would fail. If you closed the file and tried to read from it, it would fail, and so on and so on and so forth. Right? There's lots of reasons why this function could fail. Okay, so here's how you open up a file for reading and read the entire we're going to read the entire contents one character at a time. Right, so I need a file name. Right, so that's just the name of the file to open. This can be relative path. It can be an absolute path. Right, typically it's a relative path, but you could pass in an absolute path if you wanted to. Open the file. Right, so here I'm going to open up the file for reading. Right, I'm going to check, is the pointer null? And if it is, I'm going to print an error. Right, so here I'm using fprintf to print the error. If you want to print an error to standard error, you have to say, you can't use plain old printf. Right, so printf always prints to standard out. Right, if you want to print to a particular stream, that's what fprintf is for. Right, so the f here stands for, the f means print to a file or a stream. Right, so here you have to specify the stream standard error, message that you want to print out. Right, exit one is one of the functions you can use to exit from a program. It also sets the exit status of the program. Right, so exit one sets the exit status of this particular program to 1, and if you're in bash, you can call that program and then look at the exit status to determine whether or not the program successfully ran. Okay, so fgetc reads into a character. So I'm going to have a variable to store the character. Right, I've got a little while loop here. Okay, so the way you read this while loop is, we're going to call fgetc, right, to read in one character. We're going to store the value in C. Right, in an assignment expression, the value of the assignment expression is the value that gets assigned to the variable. Right, and so if we don't assign EOF to C, that means we successfully read in a character. Right, I'm just going to print the character that we read into the to standard output. Right, so I'm going to use putchar just to print the character. Right, putchar is the same as puts, except it prints a character instead of a string. Right. Eventually, I'm going to get to the end of this file, right? And so when I try to get a character from the file, I'm going to get EOF. Right? In that case, the loop will end, and then we make sure to close the file at the end here. Okay, so there's the program. Right? So it's called read file. Right? If you run it, so it's going to open up this file temp.txt, right? And it's going to print out the contents of that file one character at a time. Like that, right? And if you look at the contents of temp.txt, you can see it's exactly what was there. Right? Okay, now if you want to, instead of reading in a single character at a time, it could be the case that your file is line-oriented, right? So instead, it consists of a bunch of lines, and you'd like to read in entire lines at once. Right? And so a line is just anything that ends with a new line character, right? So \n. So fgets, not surprisingly, is the function that reads in an entire line as a string. Right? So fgets reads that stream, tries to read in the entire line, so everything up to the new line character, and store that into the string that the caller provides. Right? Now remember that that string is just some array somewhere, so it has some finite size. You have to be careful not to write too many characters into that array. So that's what the variable count is for. Right? So count is the number of characters plus 1 that it will. So count is the maximum number of characters that fgets will read up to and including the new line. Right? So it reads at most count minus 1 characters because it's going to insert the new line. It's going to insert the null terminator onto the string str. Right? So if suppose you have a string, so your line is 40 characters long, right? And you pass in a count that's bigger than 40, right? that will read in the entire line and store it into str, right? So it reads in the line, stops at the new line character, stores that line in the string, right? So it doesn't keep on going up to count -1, right? It reads in either count -1 characters, either count -1 character, either that many characters or up to the end of the line, whichever is less. Right? It returns, it returns a pointer to your string if it succeeds. It returns null if it fails. Right? And so this program here is exactly the same as the other one, except instead of creating a character, we create a string or a buffer, right, a character array here, to store the contents of each line in. Right? I'm going to use fgets to read in up to, that should be, yes, so 100 is fine here. Right, so it's going to read in up to 99 characters per line, nuts, from this file f. Right? It will then print each line that it reads in to the standard output. Once we're done reading, we're going to close the file. Right? Notice the condition here. I'm just looking at remember fgets returns a pointer. Right? So if it returns a non-null pointer, then it successfully read in the string, right? If it returns null, for example, when it gets to the end of the file, then we know that there's nothing left to read. Right? So we're just checking whether or not the pointer that's returned by fgets is null. Okay, so that thing there is read file lines. Right, so it's that program there. Temp2 is going to look like a bit of a mess, but that's because I recycled it from last year. So temp2 is just a file, with a bunch of lines in it. Right? It's got these funny pound signs everywhere because there's another program that I'm going to show you in a little bit later on that replaces a single character, every occurrence of a single character in the file. Okay, so does this actually work? Read file lines, and yes, it does. Right. All right, so moving right along. There's fget C again. There's fgets. Okay. So this is the slide set number 27. Oh yes, gets. All right, so if you want to read standard input, so if you're writing a program and you want to read the keyboard for some reason, which is a common operation that new programmers are often asked to do, then a lot of textbooks will say you can use gets. Right? So gets reads standard input into that string. Right, so in other words, if you type something into your keyboard and press enter, gets will try to read everything you typed in up to the new line character. Does it keep I don't think it keeps the new line character. Right? So now the problem with that is that you can type in as much as you want before pressing in the new line before pressing enter. So gets has no way to know how long is the string that was typed in by the user. Right? It assumes that this pointer here is pointing to an array that can actually hold all the characters that were typed in, right? But that's not necessarily the case, right? So if you allocate a buffer that has 10 characters in it and somebody types in 1,000 characters and you use gets to read that in, it's going to blow up your buffer, right? And so it's super useful because it's really easy to get input from the user this way, right? So it's very useful for new programmers who want to write a simple little program to get the keyboard input, right? But you should never, ever use this function in production code, right? Because there's no way to control how long that string that's being read in. Sorry, there's no way to control how much information has appeared on standard input before the new line character was entered, right? So there's no parameter indicating how many characters should be read into this string. Okay, so this is going to be, what is this? Read keyboard. All right, so this is a little, so this is, so read keyboard is going to use gets to read standard input, right? So it prompts you to type in some text and press enter, right? So someone types in some text and presses enter, right? It's going to use gets to read in the text that was typed in, right? And it's going to store it into here, right? Into str, right? Notice that str only has space for 10 characters in it. So if you type in more than 10 characters, those other characters are going to go somewhere, right? And it turns out, I'm pretty sure they're going to go into unused in this case, right? And so it's going to overflow our array str, str, and end up going into unused. So here we're going to print out str and unused and see what happens. So this is read keyboard. Okay, so if we just type in like ABC, everything's fine, right? So the string ABC is in fact ABC, right? Now if you type in more than 10 characters, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So that's more than 10, right? Notice that it thinks that the string str is actually that, which is much longer than 10 characters. Oh, sorry. That's the compiled program. So that's in bind. There he is, right? So notice that our buffer is only of length 10, right? So at most, that string has length 9. But that's way more than 9 characters right there, right? And also notice that the characters past the 9, past the 1 actually, have overflowed our buffer str and gone into the second array unused, right? So they've actually gone into that array there, the extra characters, right? And that's exactly what will happen if you use gets and you try to read in more information than you have room in your array to store, right? The extra information goes somewhere, right? If you're lucky, you've got this little array here that you can catch the excess stuff in. If you're unlucky, it overwrites a bunch of your other variables or crashes your program. Right. Okay, so gets is notoriously insecure. Yes?
How is it that the string can still print all of the characters?
Yeah. Excellent question. So there's your array str. Right, so if you imagine, so arrays in C are guaranteed to be contiguous, right? So it's a continuous chunk of memory, right? So there's str. It turns out that the way this program was compiled, or the way this compiler happened to work, is that immediately after that array is unused, is the next array unused, right? So when gets reads in the characters that I typed in, so 1, 2, 9, right? Oh, sorry, 9 at the end here, right? Gets just keeps on going, right? So it just keeps on writing into memory, right? So now it writes in the 10, then the 11, and then the 12. Did I do 12? I don't remember, right? So it just keeps on writing. Only when it gets to the end of what the input does it stick in the null terminator, right? So now when you print the string, right, the way puts or printf works, it just reads the contents of memory until it gets to the null terminator, right? So it just reads all this stuff here and then prints the string that's that, right? So that's what's going on in this case. Yeah?
So what happens once it goes past unused?
Whatever is sitting out there, whatever variables are sitting out there, they'll get overwritten. If there's no variables sitting out there, something else gets overwritten. You don't exactly know what. It might not. It depends on what's sitting out here, right? Your program could crash, or something else could happen. That's why the standard says it's undefined behavior, because you don't know what's going to happen. Right? There's also no guarantee that this works, right? So on your compiler, this might not work because it may not lay out memory for the variables this way. Right? All right, but this should, sort of get you thinking, right? So if you knew how your compiler was laying out stuff in memory, you could exploit gets to write into something that you shouldn't be able to write into, right? And that's exactly how a bunch of these security flaws work, right? So gets is notoriously insecure because it doesn't limit the amount of read-in characters, right? Gets was used in one of the first internet worms. So the Morris worm, if you click on that link if you want to read about it, was the first self-replicating program that was unleashed onto the infant internet. It was released by a Cornell graduate student, I think. Anyway, the way this thing would work is it would basically try to replicate itself and propagate itself out over the network. Right? It eventually crashed the internet at that point. The internet wasn't very big at that point in time. But you can click on that link and read about that. So it used several exploits. One of them was gets. Right? So if you're in security, if you're in the security program at Queen's, I assume at some point they'll teach you how to do this sort of stuff. Right? So if you can use one of these insecure functions to access or write into memory where you shouldn't be, it's possible to do all sorts of crazy things on your system. Okay, you should prefer fgets over gets because fgets actually has a parameter that says how many characters at most should you read. Right? If you really want to be paranoid, you can always use getC or fgetC. Right? So read in stuff character at a time. That way you never worry about overwriting a buffer. Right? You're only reading in one character at a time. So you can always use fgetC. Although it's inconvenient. What's this one? Oh, this is showing you how to deal with, so if you want to deal with arbitrary length input from the user, there is you can use fgets, but again, it's awkward. Okay, so this is the same program. This one can deal with input of any length. So the way it's going to do this is as follows. So it's going to allocate a buffer of length 10. Right? It's going to use fgets, limiting up to 9 characters at most writing into that buffer. Right? And so remember, fgets returns a pointer to your string. Right? So as long as there's a pointer, as long as a non-null pointer is returned by fgets, right, it's going to print out the string. Right? And now it's going to look at the last character in that string. Right? So we're going to get the string length of str. We're going to subtract 1, right? And it's going to look, right, is that character in the null string length str? Why is it hang on just a second here. Sorry, I just want to check something here. Oh, that's not what I wanted. What is this? Read lines? I don't remember the name of the program. Sorry, not that one. Probably read keyboard 2. Yep, okay. Where'd my, oh, here, oh, sorry. Okay. We're going to look at the last character of the string and check, is it the new line character? Right? Oh, so fgets. Fgets reads in the entire line and stores the new line character. You have to be, when you're using these functions, you really have to pay attention to the documentation for the functions because they all do something very specific. Fgets reads in the line and keeps the new line character on the end. Right? So what we're going to do is we're going to look at the length of that string. We're going to look at the last character in the string and check if it's the new line character. Right? So if it is the new line character, then we know that it actually read in a complete line of text. Right? In other words, we know that we're done. We know that we're done reading in that line. Right? And so then I'm going to set my pointer to null, and that's going to stop the loop from running. Right? If I look at the last character in the string, and it's not the new line character, I know that there's still some stuff left on standard input. Right? And so I'm going to call fgets again. and read in the next 9 characters of text. Right? So this one repeatedly reads in 9 characters of text until it sees the new line character, at which point it knows it's read in the entire line. Right? But notice it's not just one simple function call here. Right? You have to write a little loop, and you've got to deal with looking at the last character every time. It does in fact work though. So read keyboard 2. Okay, so enter in some text. So I'm just going to read in a bunch of text. Right? That's much longer than 10 characters. Right? And so, but it successfully manages to read in everything. Right? So I guess it's, well, I don't know a minute. Right? But it does successfully read in everything. Right. Okay. So if you want to read formatted input, so if you have a file that's line-oriented and the information is formatted somehow, right? So maybe it's all numeric data, separated by spaces or commas or something else, right? Or it's some string followed by some string, followed by some number, followed by something else, followed by something else, right? And then one way to do this is to use fgets to read in the entire, is to use fgets to read in the entire line, right? So you read in the entire line into a string, and now you break up the string into the pieces that you want, right? And so you can break up the string maybe using strtok, right? There's another function called scanf, which we haven't seen yet, but we'll look at that shortly, right? And so that's, you could definitely do it this way, right? So this is probably the most sensible strategy, right? Because fgets will read in an entire line of text, right? It's going to deal with any errors, or any errors that you encounter while reading in that line are easy to detect, right? fgets either returns a pointer to the string or it returns null, right? So if it fails to read in the stuff, you know right away that because you get the pointer back and it's null, right? If it successfully reads in the string, now you can break it up into the individual pieces, right? And so here you can use strtok or scanf to try to scan the string for the individual pieces of information, right? And now you can deal with any of the parsing errors, right? So for example, if you're expecting to see a number, then a string, and you just get a number and a number, right? Now one of these two are able to tell you that you are missing one piece of information, right? So that splits up the I/O error handling and the parsing error handling. Right. You could use fscanf or scanf on its own. So there is a way to read in formatted information from a file. So you can ask for an integer, then a float, then a string. But now you have to deal with the fact that you could run into an I/O error, so reading from the file error, or you could run into a parsing error, right? So in other words, you're expecting int double float, int double string, and you actually get back an int and then something else. Right? So we'll look at fscanf in another, I think in the next lecture. Definitely in the next lecture. Okay, so we looked at reading characters, reading strings from a file. What about writing characters or writing strings to a file? Right. So fputc is the function that writes a single character to a file, right? So it writes the character ch to the file stream, right? If it returns EOF, then it failed to write to the file, right? Oops. Fputs. Oh, sorry. You gotta do that. Okay, so fputc writes a character, fputS writes a string. Right? So fputs writes the null terminated string str to the file stream. Right? It returns EOF on failure. Right? So if it's unable to write the string to a file, the return value is EOF. Okay, so printf we've seen in the course, right? So we use printf to print formatted information to the console, right? So printf %d prints an integer, printf %f prints a float, et cetera, et cetera, et cetera. fprintf is the exact same thing, except it now prints to a file, right? Instead of the standard output. Right? So it's exactly the same. So fprintf, right? This is the formatting string, right? So anything in this string gets written to the file. If there's a conversion token or a conversion string here, then it's going to try to convert the next argument using that conversion. Right? So to print a car, it's %c. Right? So that's going to try to print the character A to the file. Right? %d is an integer, so it's going to try to print the -100. Unsigned int is u, right? So it's going to try to print 1999. Long is ld, right? So we're going to try to print long max to the file. Double and float are just %f. So here we're going to write 1.0. To print a string, it's just %s, right? And of course, you can mix up a bunch of values if you want to, right? So %c, %d, space %f, s, sorry. So %c is going to print the c. %d will print the 99. Then you'll get a space, and then %f will print we, right? So you'll get C99 space we written to the file, right? So if you run that, that will write to formatted text. And hopefully I have that here. I do. So there you go, right? So it prints out the contents of the formatting string, right? Followed by any conversions that the formatting string is asking you for. Right? It works exactly the same as printf, except it sends the output to a file. Demo. Okay, do we want to do this? Sure. All right, so when you write to a file, there's the notion of actually when you read or write from a file, there is the notion of a file position. Right? So the file position points to where the next character is going to be read or written from in the file. So the easiest way to think about this is that your file is just a giant array. Right? The file position is just an index. Right? So the file position 0 is the start of the array, or the start of the file. Right? When you open up a file for reading or writing, it's always, the file position is always the beginning of the file. If you open up a file for appending, the file position is always at the end of the file. Right? If you read or write, read from or to the file, right? So if I read in one character from the file, then the file position moves one character forward. Right? If you write one character into the file, then the file position moves one character forward. Right? So it's literally like moving through an array. And just like regular arrays, at least in Linux, you can jump around in the file. Right? So in other words, you can you can set the file position as though it were an index and jump to that position in the array. The one thing you have to remember is that if you open a file for appending, right? So if you append, then then all of the writes always happen at the end of the file, right? It doesn't, in this case, so that in other words, the file position is ignored in this particular case, right? If you open up the file for appending using a+, so append plus you can read from the file as well, the file position affects where the reading happens. Right? But it doesn't affect where the writing happens. Right? So append always happens at the end. Okay, so you can basically treat a file as though it were an array. To change the file position, there are several functions that let you let you manipulate the file position. So ftell tells you what the file position is. fseek lets you set the file position. Rewind puts the file position back to the start of the file. Okay, so ftell is basically telling you what is the file position for this particular file. Right? So it returns back some value. you don't actually care what that value is because you're going to pass it to one of these other functions. But that tells you what the current file position is. Right. Okay, so here's the file that I'm going to use for the purposes of this demonstration. So I have a file called tel.txt. It's just 4 lines. Each line has 5 characters, plus the new line character at the end. Right, so each line actually has 6 characters in it. Okay, so I'm going to use, ftel here. I'm going to call ftel to get the file position and store that in the variable POS. I'm going to read the file 1 character at a time using fgetc. Right? Every time I read in a character, I'm going to print the character and its file position. Right? And then, of course, I'm going to update position each time. Right? So we can see how this actually works. What is this called? This is tel. Okay, there we go. So remember, our file is ABCDE, new line, FGHIJ, et cetera, et cetera, et cetera. Right? Okay, so the A, that's at position 0. Right? The B is at position 1. The E is at position 4. The non-printing character here is actually the new line. That's why there's a skipped line here. Right? So that's the new line character is at position 5. Right? And so you can see that the position is just an index. When you get to the end, so the last new line character is at position 23, which makes sense, right? We have 4 lines of 6 characters per line, right? And so the last index should be 23, right? Indicating that we have a total of 24 characters in the file. Rewind sets the file position back to the start of the file. So that's all it does. Right, so this is useful. So for example, you might need to read a file more than once, or you might need to read parts of the file more than once. Right, so for example, if I ask you to read in, say, a file containing a bunch of numbers, 1 number per line, right, and I say you don't actually know how many numbers are in the file, right, but you have to store them somewhere, right, and then the easiest way to do this is read the file once, count how many numbers are in the file, dynamically allocate your array to hold all those values, and then read the file the second time, right? And so that's what rewind is used for, right? So you can rewind the file without closing it and then reopening it, right? So rewind, go back to the beginning, read it again, this time reading each value into your newly allocated array, right? So this one just, this is tel forever. So this one, when we get to the end of the file, it just rewinds the file, right? And so this is going to read that file forever. It's the same program otherwise, right? So this is tel forever. All right, so it's just going to keep on going. Right. All right, and finally, well, actually, let's not, this is going to take a little bit, so let's stop there. And we'll finish this lecture up on Wednesday. Okay, last assignment comes out later this afternoon.